in a triangle, the 45-degree angle, the fraction's always going to reduce to the same thing. And so what I do is I'm going to make AC 1. This is a 45, 45, 90 triangle. Okay. And if I did that, if I made that 1, what do I know about BC? 1. Okay, in our heads, let's do some Pythagorean theorem. 1 squared plus 1 squared is 2. This side is the square root of 2. Okay. So what we have then is if you would take any 45, 45, 90 triangle and reduce the fractions, you could get the same ratios. Okay, these same reduced ratios. One other quick thing, only in exact ones do I care about this. It is not proper to have a radical on the bottom. Did you guys know that? So we have to rationalize it. I'll show you how that works. Okay, so let's find then the sine of 45, and we can take either of the 45-degree angles because they're the same, is opposite over hypotenuse. So I do 1 over root 2. Okay, however, there's a radical on the bottom, right? So what we do is we multiply by root 2 over root 2, and that's going to remove that on the bottom. It can be on the top. On the bottom, root 2 times root 2 is 2. On the top, we have root 2. Okay. So this is the original form. This is the proper form with no radical on the bottom. Okay. Well, what's true about cosine then? Same, right? So let's not do all the blah-bitty-blah. We're going to just go straight to the simplified proper form would be root 2 over 2. And how about the tangent of 45? One over 1. It's just 1. Okay. Let's do, just while we're at it, let's do the reciprocals. Now, here's the deal, guys. Don't memorize cosecant, secant, and cotangent. Because if you just know that the cosecant is the reciprocal of sine, then, yeah, you just have to memorize 3 of the things. Okay. So, and if you want, just every time I used to, when we get to unit circle will be easier. I used to just draw a little triangle, 1, 1, root 2, and then I just didn't even have to memorize anything. If I flipped this, it would be 2 over root 2, but that's the improper form, so I'd have to do that whole business again. If I flip it in the improper form, that's easier. Don't I get root 2 over 1? Okay, so cosecant of 45 is just root 2. The secant of 45 is the same, it's root 2. And what's the reciprocal of 1? 1. Okay. Yep. All right. So most important is realizing that the ratio of any 45 is a 1, 1, root 2. This is how a 30, 60, 90 works. And I don't know how your geometry teacher taught you this, but what I always do is I draw an equilateral triangle. What's an equilateral triangle? All sides and all angles are equal. So all of these angles are the same. They're 60, right? Would you draw the altitude? The altitude is the height of the triangle, so it makes a 90-degree angle with the base. Would you agree that in an equilateral triangle, that's going to split the base in half? Okay. So, ABC is equilateral, so each angle is 60. It says to call the point of intersection D, so I'm going to call this D right now. What is the angle, the measure of angle BAD, angle bad? Yeah, we just split it in half, so this is 30 degrees. All right. So here's what we're going to do, and we're going to use this for 30 and 60. I want all of AB to be 2. And the reason why I make it 2 is because I'm going to have to take half of 2 here, and I don't want it to be a decimal. So If AB is 2, what's AC? 2, and the whole thing, BC, is also 2, but can I split it into a 1 and a 1? Okay. Now, here's what I want us to look at, okay? And you can take a highlighter if you want. I got a new highlighter. The little things in life. I'm going to just take that triangle. If you wanted to, you could do this one. Let's just look at the highlighted triangle. This is now, you guys told me, this is 30, right? What's this angle DCA? 60. So this is a 30-60 triangle. The hypotenuse is 2. This is 1. If you did Pythagorean theorem, you're just going to have to trust me. You can work it all out. This is root 3. Here's why. 2 squared minus 1 squared is 3. Take the square root because it's Pythagorean theorem in reverse. We know the hypotenuse. All right. Let's find, we'll do 30 and then we'll do 60. Okay? Okay, 30 is up at the top. What's opposite 30? What length? 1. Over hypotenuse. 2. Cool. All right. Cosine of 30. What's the adjacent piece? Root 3 over 2. And tangent of 30. Opposite over adjacent. 1 over root 3, except I'm not going to leave it like that because it's got a radical on the bottom. So what do I need to do? Multiply by root 3 over root 3. Root 3 times root 3 is 3. 1 times root 3 is root 3. Okay. And we said that 30 is the same thing as pi 6. So if you want to put that on this one. Okay, so let's use the same triangle. And by the way, what would we do if we had to do secant, cosecant, and cotangent? Yep, flip those around. Let's do sine of 60. So now I'm looking at the bottom. What's opposite over hypotenuse? Root 3 over 2. And I want to point out to you the sine of 60 is the same as the cosine of 30 because 30 is the other angle, right? You're just kind of changing your perspective there. What's the cosine of 60 then? Adjacent 1 over 2, same as the sine of 30. And then the tangent of 30 is, 60. I meant 60, sorry. Root 3 over 1 or root 3, and we don't have to rationalize that. Okay? And we said this was the same as pi thirds. Okay? So, questions?